Hello everyone, my name is Azka Mulla and I am currently pursuing my BTech degree in Computer Science. In this video, I will be explaining a topic from the subject Compiler Design, which is a part of our academic curriculum. The topic I will cover today is syntax directed translations for case statements. I will try to keep the explanation as simple and clear as possible. So, even if you are just starting with the compiler design, you will be able to understand it easily. Let's begin. The content of my topic is first, what is STD or what is syntax directed translation? Second, what is a case statement? Third, STD grammar for case, semantic actions, sample STD actions, example code input, output intermediate code, and last but not least the summary of my topic. So first let's understand what syntax directed translation or STD means. It is a technique in compiler design where we attach actions or rules to the grammar of a programming language. STD helps the compiler perform tasks like generating intermediate code, building symbol tables, and performing type checking. It connects syntax, which means the structure of code, with meanings or semantics. What is a case statement? A case statement or switch statement is used in many programming languages to choose between different options based on the value of a variable. Here is a simple example in C language. Switch X, case 1, case 2 and case C. In case 1, the statement 1 will be do something, or in case 2 do something else, or in default do something by default. This is much more readable and clean compared to writing many if-else statements. Moving to the next, STD grammar for case. Now let's look at how STD is applied to case statements. We define grammar rules like switch becomes switch with an expression and a list of cases. Case list can be multiple cases, and each case has a number followed by a statement. When we then attach action to these rules to help generate intermediate code during parsing. Now, semantic actions. When we apply STD to case statements, the key steps are: first, evaluate the switch expression and store it in a temporary variable. Next, create labels for each case option. Then compare the switch value with each case number. If it matches, jump to the cases label and execute its statement. After each case, we jump to the end to avoid running other cases. So here is sample STD action. Here is how the semantic actions might look in practice. We create a temporary variable to store the value of the expression. We use emit functions to generate lines of intermediate code. Then we handle each case by generating labels and jump instructions. Finally, we define an end label to finish the switch block. This all happens automatically as the compiler reads and parses the code. Sample code input. Let's take an example switch block in C. If x equals 1, set y to 10. If x equals 2, set y to 20. Otherwise, set y to 0. Now, let's see how this is converted into intermediate code using STD. The output intermediate code will be: we first store x into a temporary variable. Then we check if the value is 1, go to label 1. If it's 2, go to label 2. If neither, go to L3, which is a default case. Each label does its job and finally jumps to L4, which marks the end. This code is much easier for a machine to execute and keeps our logic clean. To summarize syntax directed translation, helps us convert high level case statements into intermediate code that a compiler can understand. We use grammar rules, semantic actions, and labels to manage the logic of the switch statement. This makes compiler processing organized, systematic, and efficient. Thank you so much for watching this video. If you found this explanation helpful, please like the video, share it with your friends, and subscribe to my channel. This is Azkamullah signing off. Keep learning and see you in the next one.